Hello everyone, welcome to my channel Aptitude Club and welcome to this video where we'll be discussing this beautiful question from numbers theory and logarithms combined. So it's a very good question, not very difficult, but two fundamentals are used together. And at first, maybe the question might look a little intimidating, and people might skip this question if it is asked in the exam. But not always the questions are the way they look. Okay, and that's what I'm trying to explain through my videos. If you have missed the previous videos, definitely I'll request all of you to explore the channel and watch the previous videos and questions that have been discussed. Now, as usual, I'll ask all of you watching this video to pause at this moment and maybe try the question yourself first and then look at the explanation. Now, to understand this, I'll just give you a brief context of what factor theory is all about, and then we'll try and build on the question. Basically, if any number is given, so the first step is you prime factorize the number in this form: a to the power p into b to the power q into the c to the power r and so on, where a, b and c are prime factors of n. This is called as prime factorization. I hope all of you understand this. Given any number, the first step is you prime factorize. And once you have prime factorized, then we can calculate the total number of factors of that number using the formula 1 plus p into 1 plus q into 1 plus r and so on. Similarly, we can calculate the sum of factors of the number. If I add all the factors, then it is given by the formula a to the power p plus 1 minus 1 by a minus 1 into b to the power q plus 1 minus 1 by b minus 1 into c to the power r plus 1 minus 1 by c minus 1 and so on. And finally, if I multiply all the factors, product of all factors of n, it is n whole to the power total number of factors divided by 2. Okay, these three formulas belong to factor theory. I have done a detailed video on factor theory and I have derived these formulas. I'll pin it in the I section. You can check it out after solving this question. How are these formulas derived? Remember, in mathematics, do not try to remember anything. Try and understand if you are using a formula, what is the background of it, how it is applied, how the derivation has come up, because that will enhance your thinking process when you are looking at a new question. And that's all we are targeting. That is a skill you need to acquire if you really want to crack such exams. Okay, so these are the three formulas that we'll be using to crack this question. Now let us go to the question. If f1, f2, f3 till fn is the list of all the factors of 10 to the power 100, that means basically 10 to the power 100 has how many factors? These are all factors: f1, f2, f3 till fn. That means there are n factors. So 10 to the power 100 will have n factors. Total number of factors of 10 to the power 100 is n. Now, can I get the value of n? Yes, using this formula, because once I have the number, I can prime factorize the number and then calculate its total number of factors. So that can be done. So if that is the case, and here the bracket, it has been mentioned also, the number of factors of 10 to the power 100 is n. Then we'll have to find the sum of this expression. Log 10 to the base 10 f1 plus log to the base 10 f2. So very beautifully, factor theory and logarithm has been combined. So let us first figure out total number of factors of 10 to the power 100 is how much. So to do that, first we have 10 to the power 100. Let me write it in this way. It is 2 into 5 whole to the power 100. So it is like 2 to the power 100 into 5 to the power 100. Now this is the prime factorization form. So that means total number of factors of 10 to the power 100 is like 1 plus 100. 1 plus p here is 100 into 1 plus q here is also 100. 1 plus 100 into 1 plus 100. So basically it is 101 into 101. So 101 square. So it is 10201. This is the total number of factors. And next thing, if I calculate product of factors of 10 to the power 100, It is a number 10 to the power 100 whole to the power total number of factors by 2. We just simply use this formula. So if you solve it a little bit, by 2 means I can write it as 10 to the power 100 by 2 whole to the power 10201 using a simple law of indices, that is a to the power b whole to the power c is same as a to the power c whole to the power b is same as a to the power b into c. The simple law of indices we used here. So now this can be written as 10 to the power 50 into 10201. 10201. This is the product of factors of n. Now we'll not need sum of factors to be calculated here. You might think why. I'll explain that a little later. Total number of factors and product of factors of this particular number we have calculated. Now what is it that the question is asking us to compute? It is asking find the log value of this expression. Now to understand this or to calculate this, again we need a few properties of log, and one basic property of log that will be used, that is if I am doing this log to the base 10, any base, common base, log to the base 10a plus log to the base 10b plus log to the base 10c, suppose. So I can write it as log to the base 10 a into b into c. So if logs are added, then their domains can be multiplied. Okay, very simple property, and this property is going to be used. So the question is asking us to find us till fn. So let me write it here. Log to the base 10 f1 plus log to the base 10 f2 and so on till log to the base 10 f of n. Now see here, because logs are added, I can write this, it is f of f1 into f2 into f3 till fn. Now if you observe here, the expression that we got here, what is basically this? This is basically the product of factors. So we are concerned about the product of factors. So a whole question is based on product of factors, and to calculate product of factors you need total number of factors. That is the reason I calculated these two. Sum of factors has no context in this question. Maybe some other question it will be used. So I can write it here. Product of factors we have already calculated. Product of factors, it is 10 to the power 50 into 10201. So it is 10 to the power 50 into 10201. Now another property of log can be used here. Let's say this is property 1. The second property is, suppose I'll write log to the base 10 a to the power b. The power comes to this side and gets multiplied, so it is b times log to the base 10 a. So I can take out the power and multiply it in this manner. So that we can use here. So this is the power, so this will come on this side. So 50 into 10201 into log to the base 10 10. Now this log to the base 10 10, this value is 1. So I got my answer then. 50 into this much. So if you multiply 5 then 0, here it is a 0, 5 to the 10, 0 carry 1, 510050. Very simple question, and this is my answer. But our fundamentals need to be in the right place to be able to solve this question. Log, not very significant application, just a few properties of log we need to know, but then we'll have the structure of thinking. That is what matters. Given the number, first calculate the total number of factors, reach at the product of factors, then automatically we're seeing that okay, when I'm solving this, so basically I have to multiply all the factors, so I need product of factors. To calculate product of factors you need total number of factors, and then the question is very simple. Okay, a good question, numbers and log combined. Hope all of you understood the explanation, and you need to solve similar questions to be able to enhance your application skills. Do check out the previous videos that I have done on this QA booster playlist and other videos as well on the channel. You'll definitely like it. If you have watched it this far, do subscribe to the Aptitude Club channel if you like the content. and I'll keep posting more such videos. I post videos regularly, almost every day I post one video, and it will definitely help you on your CAT preparation journey. We'll meet again very soon on yet another video. Till then, keep solving, keep studying, and thank you for watching. Bye bye.